Good afternoon. We shouldn't make a break, so we lost audience now. Sorry. So, it's here. Okay. Let's go this. So, it's not necessary sometimes, but it is really now more and more necessary to always remind about climate change and climate global warming, but recently I really did start to describe what is happening like climate chaos. It is partly a result, maybe, on the concentration in cities, bad technologies, dirty technologies, villages are drying, and it is happening in Serbia, happening in China, in many other parts of the world. Definitely, first, mathematical and rational, real precise theory about climate concerning the space, motion on planets and sun was Milutin Milanković, and it is possible to implement today because we have equations and we have to try to calculate what is really effective coefficient of absorption of the space. And naturally, it is necessary also to take in account astrophysics, and they are also very important concerning interaction of S. So, migration, political problems, immigrations. In the same time, technology. There was today talk about thermal, solar thermal, but it is an exergy, and it is exactly increasing and very quickly increasing the implementation of electrical conversion of solar radiation to photovoltaic. And that technology made a record in the history of technology in the world with the biggest reduction of price from the moment the technology did appear and today. It was a few months ago 11 times reduced the costs, and maybe today it is even more. So different possibilities in glazing, in opaque surfaces of enveloped roof and so on. So building integrated PV exactly is replacing one layer within the structure of building envelope. A solar decathlon happening in US, Europe, next year there will be the first in Middle East, did show that it is possible to obtain results which are really remarkable. Here we see Schneider microgrid. So all houses very normal, not very with very special PV. I mean, not very innovative, but just on the level of current technology, was enough to get houses which were producing more, 2 to 4 times more electricity than they were using and sending to the grid. Even this was in 2014 in Versailles Park, even during days which were not really too much rich in sun. So implementation, different type of implementation of building photovoltaic. Here are just a scheme of heat transfer, relevant processes. So it can be second additional facade, it can be glazing in the window, and it can be really used actively within the process of heating, ventilated air conditioning, like here, because the PV layer, PV cell, are to be on the optimal temperature to have the highest efficiency, and that is approximately 24-25 degrees. So you will see here 2 types of implementation: summer configuration, when it is used exactly this air to flowing behind the PV glazing, just to reduce even cooling loads from result of solar radiation. Winter configuration can be in other direction, we can, this flow of air used to preheat ventilation air. The problem naturally with the implementation of building integrated PV, it is no problem when in rural areas, when we have not shading from different houses in between, but in dense urban centers, it is not so easy. So, example of social economic, status, and the way Rurban as a system was developed in Switzerland is model for all. So, small cities surrounded with agricultural land and people producing food production, and they are perfect locations for installing building integrated PV. And also there is a rule in Switzerland that only on the roof and only on building can be photovoltaic or any other solar used. So not on green surface. So big solar power plants are simply not permitted in Switzerland, and that's also very important to be aware about. Whether wind is different, so wind can be, although there are also some not enough known bio effect. What is very important, and that is the main, target of my presentation and speech, is that how we can get cost-effective implementation of solar energy. At first, I say today electrical energy, because electricity is definitely need for all aspects of life at the standard we need. They provide also for people in cities, but also people in rural area. It means for all Rurban people. So it is necessary at first to implement definitely in all kind of design detailed analysis about loads, so dynamic analysis of building behavior, thermal energy, so building performance simulation. So designing any kind of system in buildings today just using summer or winter design temperature is simply not anymore enough. So absolutely 80,760 hours are necessary to do analysis. Sometimes even in shorter, for some period, shorter period of time. There is a lot of software available and even free downloadable software, Energy Plus, for example, and it is not explanation that somehow it is expensive to certain. Here is a list. Maybe you have seen examples of in different situations and different kind of projects I had. There is social building in Belgrade. It is possible to see that in this available calculation, there 5 times could be reduced loads for heating and cooling. And you see that nearly all apartments have these split units, so it means they are using air conditioning. And air conditioning will be more and more needed because of global warming and increase of temperature. When we are approaching refurbishment, we have to try using different models of building envelope refurbishment and analysis, as I said, building performance simulation, to minimize loads. Absolutely always is necessary to minimize loads and have the goal not some nearly, what is even not engineering term, but to try to reach net zero energy building. Like I said, it was shown in all solar decathlon that it is absolutely possible, only if house is not under the shadow. Oh, excuse me. Here is example how, for example, second facade, it's different ways how it can be implemented photovoltaic. And second, this, when we minimize loads, and everywhere where we have either air or ground or water, so environment, and it is possible to use this environment and to use that as a source for energy and implement heat pump where we are increasing exactly the exergy, we can say even of the system. And in that case, we can always, I did show that in projects in the different climates and with different prices of electricity, expensive, Singapore, cheap, for example, Russia, and so on, that everywhere result is cost-effective implementation and even possibility to power those systems always by photovoltaic. Naturally, I did show these previous slides just to show that everything is to be calculated, every project with the highest knowledge, engineering and scientific of today. So, for example, use of underground for heat pump as a source deserves to also do CFD analysis and to locate inlet and outlet on the right place. So no approximation, no rough, and no just, there are many projects that typography of houses. You cannot do with typography any renovation and to reach net zero. Every house needs own analysis. The nicest example, it was recently sourced Cipser journal, so you see for this kind of refurbishment, like in previous social building, when you have many split units, then implement heat pump, groundwater, and so on, and you have here plate heat and change and ground loop pump to form for providing all apartments. Downtown center, it was very interesting project, different several models analyzed, and very interesting also and useful for detailed analysis, train trace model, as well also Bentley model has also possibility to analyze very detailed all component of HVAC system and their need in operation at different temperatures. This building final result was that it was cheaper to do refurbishment, to implement even PV, then to including drilling and for heat pump, then to stay in the district heating of Belgrade, because they have only the one size is a minimal size of the district machine room. Traditional Serbian house, as all traditional houses in the world, is bioclimatic. Bentley analysis was done, and necessarily all data were found, weather data, that was very interesting graph which we did find. You see, it is on ordinate the lengths of period and down end of period, and how the surfaces with higher temperatures are growing as it is later and later done. Groundwater fine availability in Serbia, so the final result after using all this fine data of Hydrometeorological Institute, radiation, groundwater temperature with different models. Here, reduction of energy loads was obtained, cooling and heating, and as a final result, it was zero fossil energy house as a final result. So you see lower surface of PV and PV minimum and PV maximum, that on the right side with this PV maximum, all these light yellow are plus producing and sending more to the grid than they need. Use of subgeothermal, that's new term by the mining faculty in Belgrade, they started to use and should be, I think, changed in terminology of ASHRAE and also European Association RIVA, because it is really not geothermal. Geothermal has here impact, but also from the outside solar radiation. So till this 12, 15 meter, that is subgeothermal, and use is resulting with very stable temperature in that layer and different kind of implementation of use of sources of groundwater wells, ground heat exchanger, borehole heat change, and even construction, and so on, available in literature, particularly in German Verein Deutsche Ingenieur standards. Large scale, so all these examples show that it is possible to design cost-effective system. The main problem which is addressed and should be more and more in trying to find a solution, it was in several presentations stressed today, it is a problem of intermittency. So intermittency of solar, of wind. And there are also possibilities to solve that problem and abundant mines. Abundant mines of coal and some minerals can be used for storage, thermal energy storage, but also electrical, hydromechanical and electrical energy if we have mechanical. Abundant mines, there are a lot in Serbia, in many regions, and not only, I mean, underground one, but also surface mining is leaving surfaces which need geological cultivation, but can be used for energy storage. Analysis in solar energy laboratory in Golden in Colorado, they did excellent thermal energy. In Romania, they had also excellent studies on thermal energy storage particularly, and concerning laboratory in California, in Golden, or not California, but Colorado, high energy batteries, pumped hydro storage, compressed air energy storage, and thermal energy storage are technologies which can be implemented to have also mechanical energy storage. It is like reversal hydro power plant. Here are some underground thermal energy storage concepts and underground thermal energy also storage, aquifer, boreholes, caverns, and so on. Yeah. And there are more and more example of these mines, energy deposits in Serbia, and many of them are close to their exhaustion, and there are some abundant. So somehow they are in some countries also used for a touristic purpose, but this abundant mine can be again useful also for heating our homes. So that's about storage. Solar energy technologies current status, absolutely, I stressed even in the beginning of presentation that it is huge advance and reduction in prices. And there is also, and I will conclude with that example, that these technologies, if we have concerning solar PV, especially if used in extraterrestrial space and using extraterrestrial solar radiation, could be provided quantitatively, qualitatively by the exergetic higher value, more reliable, sustainable energy to serve. Nikola Tesla more than 100 years ago, what he was stated here, it is really very, very even touchable, that his innovation and what he has done and his result will provide people with transfer of power long distances, as we know, based on his invention, are to be replaced by wireless transmission, whose principal method he had also developed more than 100 years ago. And there are some ideas also from other people about how this power could be used from the space even in 1891 in US in some lectures. And here are what I mentioned touchable. So after this discovery, Nikola Tesla wrote, "The human voice and likeness will be flashed around the globe without wire, energy through space. The wastes of the ocean will be made safe to navigation, transport facilitated, rain precipitated at will, and perhaps the inexhaustible store of energy released. Advances of this kind will in times to come remove the physical cause of war, the chief of which is the vast extent to his planet. The gradual annihilation distance will put human beings in closer contact and harmonize their views and aspiration. The harvesting of forces from nature will banish misery and want and provide simple means to safe and comfortable existence. How, based on this idea, very intensive research and the roadmap and real work to realize this idea are in China and also in Japan. So precise map in Japan, roadmap is by Mitsubishi Heavy Industries. But what is happening these days with this world, and when you read newspapers and especially first pages, then it looks that it is much more difficult to realize what was Tesla speaking about implementation of this result, about space, extraterrestrial space, solar energy utilization, that it was in Tesla time 100 years ago when he was working, because there were some nations and some people there asking even to put weapon, even extraterrestrial, in space. So that's very, very important. And besides science and engineering, we have to think about new society in the world. So in order to stop the global climate change, in addition to the uninterrupted R&D aim to advance solar ability and other renewable resources technologies, it is necessary to find relevant circular economy-based schemes of multi-sector complex systems, linkages for sustainable Earth resource utilization, environmental protection, and already damaged environment recovery, uninterruptible availability, and variable quality of most types of S requires energy storage. Large-scale renewable energy storage utilization needs a large-scale storage system and large storage volumes. Worldwide, many mines of coal minerals offer large storage volume, ready-made exactly to be used directly for energy storage. There is one idea in Serbia that one of surface mines will be placed that we can design and try to do that kind of project, not to say experiment, but try to implement the system. So using thermal energy also from environmental heat pump are increasing energy efficiency and contribute to the reduction of primary energy demand, particularly heat pump use of the underground enables high efficiencies on an annual basis. So solar, space, terrestrial, and so on. And that is exactly my conclusion. There is one way to reach. I am repeating on, it's the last slide on my note. These are to my grandchildren, but now they're much bigger. One way to reach sustainable development, it is the way we harmonize and ethics of sustainability, or to war, produce weapon. I'm always wondering, we are obliged to give for any renovation payback period, for any construction or implementation also solar and renewable energies also payback. And those producing killing tools, what kind of payback they have. Thank you very much for your attention.
Thank you, Professor. Are there any questions from the audience?
Yes?
Thank you. Thank you for your presentation. It's always nice to hear you talk. We are actually looking at one of these old mine, which they will warm up with solar panels and then use it for heat pumping.
Where are you?
In Germany.
In Germany,
yeah.
Oh. I know in Germany, they're in Germany, in Canada, and
yeah, but my question is more, have you considered, because we are a little bit worried about what can be in these mines and how will it react with our heat exchangers and metals?
About?
Corrosion, basically.
Corrosion.
Yeah. Do you have any opinion on what can happen?
At the moment, this project which I mentioned yet didn't start, so that part is not yet in. But there must be results, I mean, as those who are constructing mines, so that's their job.
Thank you.
So there is a knowledge of that.
Professor Todorović, I would like to congratulate you the 50th anniversary of this conference we attended today, and my congratulations for an excellent presentation. And regarding your presentation, I would like to add just one more energy storage, that is the methanization of the hydrogen. That is one technique used in Germany. And I would like to pose the question regarding the ideal HVAC system from the perspective of reduction of CO2. According to your opinion, what it would be? What kind of system? Is it a combination of, is it a district heating system?
If it is?
District heating system, district heating and cooling system. I think that it is the system of the future from the point of reduction of CO2 emission. And I would like to hear from you, what are your thoughts on that issue?
Thank you.
Thank you.
I mean, this kind of projects is absolutely necessary, and that's exactly only way to be done with good result are to be interdisciplinary, multidisciplinary. This is multi-sector project. And so every aspect of it is to be done, I mean, with the best and highest scientific and engineering knowledge in that field. For example, this some simple and houses of solar decathlons you didn't see. First, Romanian building, all traditional, then this winner in Rome and on. They were exactly example how everything was finely integrated. You know, everything was just let's say, not extreme special high technology, HVAC, or no, just a level of, let's say, average technology, but harmonized with the building, thermal, and so on, you know. And what is also partly can answer you is that it is easier to make net zero neighborhood. It could be connected with certain district heating and cooling, than just one house. But because it is a result of smart grid operation. So smart grid in one building, it was one slide, you had also shown that there is a battery. So when it is available radiation, it is, and the PV, electricity, is immediately turning on appliances, battery and appliances. And if there is more available in that moment, smart grid is sending to other houses in that neighborhood, because there was also a slide with many houses. And then also satisfying needs of all houses. Only after that, if there is surplus, then it's sending to the grid. So integrated building design, integrated project delivery. So immediately from the beginning, all engineering sectors are to work together till the end. And this project, which I mentioned, that could be done, is to be also done that way. Everything what is best known today is to be implemented. No simplification, no, and always trying to go forward. So many of these European projects, nearly it's totally, not acceptable, it's not engineering term. Then different directives that EPBD, for example, renewable sources in buildings, with the directive in 2009 first time, and then that's improved in 2018, did get right to be calculated as a contribution to country balance of renewable, 2009. And there is about heat pumps. Heat pumps can be using environment, and on that EPBP is that right exactly described this possibility. In 2009, this description about EPBD, then more, but it can be done, this bureaucracy, ad hoc, comitology, 25 pages. The most important what is for heat pumps, which were mentioned there, was seasonal performance factor. And that was just given with one equation, with no experience, not data, no instructions, no exactly available knowledge. Next time, when it is again the same, but somehow improved in 2018, this first part was 100 pages. And this technical was, again, just this one equation. And there's so many projects which are absolutely far away. For example, stories about now, the most recent was in Brussels. Smart readiness indicator. It's simple, impossible to, many calculations, many issues, and exactly no engineering results. Money is going for that, and it is totally not useful. Only it will even remove farther from the goal investors and buildings and who want to do refurbishment and renewable energy implementation. Excuse me, I was long.
One more question, if possible. According to your view, how far we are from the moment here in Serbia when the provider of heating and cooling energy will issue to commercial customers the certificate that they actually buy the heating and cooling energy from the renewable energy sources?
You see, I thought always that it is, the fact is that the Ministry for Mining and Energy is sending reports to energy community. I thought based on that they are taking care about us and energy in buildings, but no. Buildings and energy used in buildings is duty of Ministry for Construction, Transport and Infrastructure, is that. But mining, they're sending reports to energy community. So as I did long ago, study about National Energy Efficiency Action Plan, they're sending me results. So I did so that they're putting 0 for heat pumps, our ministry. And there are many heat pumps implemented. So I think answer to a question depends on how we engineers will be able not only to do conferences like this, but to do something active, and we define definition and what incentives are to be given to companies producing, installing heat pumps, this. And when we have own decision, then government and ministry have to take actions. But as we did, it's fine. Because other way it's going worse and worse.
Thank you.
Thank you. Okay. Okay.